Hello class. Today I'll be talking about the different types of binary stars and some of the results that can come from these binary stars. Firstly, a binary star is a system with two or more stars where the stars will orbit a same center of mass or where one star will orbit the other star. The longest known type of binary would be visual binaries. A visual binary is a binary system in where we can see the stars separately either with our naked eye or using a telescope. A prime example of a visual binary that has been known for thousands of years can be seen in the Big Dipper in the stars named Mizar and Alcor. Mizar and Alcor were once used as a seeing eye test for the people, and if your vision was good enough, you'd be able to see the stars separately in the night sky. As telescopes become better, more and more stars are categorized under visual binaries as they are now able to be seen separately with better telescopes. Now you may be asking yourself, what if we can't separate the stars in the night sky? What if even with our most powerful telescope, it just looks like a single ball of light? Well, how do we know they're binary? How do we know they're separate? At this point, we take a spectra of the star's light. Taking a spectra of the light, breaking it up into narrow individual colors, it allows us to see the Doppler shift in their spectra, letting us know that the stars are separate. These types of binaries are called spectroscopic binaries. Remember how I talked about Mizar and Alcor earlier? Well, in fact, Mizar is not one, but two stars that are in a spectroscopic binary, and the same goes for Alcor. Both stars fall under a double binary, meaning that Mizar and Alcor are not one, but two types of binaries, being both a visual and a spectroscopic binary. The orbiting range of these binary systems can be very large sometimes. Some systems take centuries to orbit each other, while other systems can orbit each other in only a matter of a few hours. Some binary stars are so close that they can touch each other and they can come in contact with one another and start transferring matter between each other. Two stars that come in contact with one another form their own category of binaries in contact binaries. Let's say we have a high-mass blue star and a red dwarf in a binary system with each other with the same center of mass, orbiting each other. Our red dwarf just sits there, slowly burning through its fuel, but the same cannot be said about our high-mass blue star. As it quickly burns through its fuel, it starts to expand and let off mass. As it expands into a red giant, it forms a contact binary with our red dwarf. And as our now red giant is in a contact binary with our red dwarf, as it is letting off mass as it expands, our red dwarf takes in a lot of this mass, expanding itself, and what was once our high-mass blue star is left as a white dwarf, and our once red dwarf has now expanded and can now be bigger than our original white dwarf. I used the blue to represent the white dwarf because white would not show up on a whiteboard. Alright, let's say we leave our system for a few billion years, and then we come back. We can see what was once our red dwarf start to expand into a red giant and form a contact binary with our white dwarf, our once high-mass blue star. Now that our once red dwarf is in a contact binary with our white dwarf, it starts to release matter onto the white dwarf. The white dwarf's gravity is so strong that hydrogen can start to build up on the white dwarf as it flows from the red giant. And if the flow rate is just right, all of the hydrogen can fuse in one flash, resulting in a major explosive flare that can result in a source of light tens of thousands of times brighter than the sun. A star that was once invisible to Earth can flash into sight and are called stellar novae. In other cases, contact binaries, instead of transferring matter between one another, fuse together. Stars of similar mass and similar shape will form a peanut-like shape as the stars fuse together, and stars of different masses will form a teardrop-like shape as the smaller star fuses with the larger star. This being the peanut-like shape, this being the teardrop-like shape. In conclusion, binary stars are stars that are gravitationally attracted to one another in certain ways and can come into contact with each other, fusing together, forming shapes, or transfer matter between each other, resulting in major explosions. Thank you for watching the video. Goodbye.